Too perfect.
All right, guys, ready? Let's do some learning. Okay. We're at domain 3.1.1. So compare and contrast security implications of different architecture models. So we're just going to go over different infrastructure and architectures in an enterprise. It's always very important when we're talking about the Security Plus exam that we're looking at everything through the lens of a big enterprise, medium-sized corporate or a big corporate enterprise. Okay, so cloud architecture. I kind of went over this yesterday. So when you're dealing with the cloud, so you're L3 Harris, you're an organization, and you want to put resources in the cloud, there's going to be something called a responsibility matrix. So remember how I got hacked and I owed the money still? Yes. Google Cloud, Azure, AWS all have a responsibility matrix that says, what is the customer responsible for and what am I responsible for? And essentially the way they lay it out is like, okay, I'm AWS. If you're renting an EC2 instance from me, that's their versions of VMs, you're responsible for this and I'm responsible for this. And they'll lay it out clearly for you, okay? So if you ever engage in provisioning, monitoring, whatever in the cloud, you probably want to take a look at that prior. And it's always going to vary depending on your service model. We went over this yesterday. Okay, hybrid considerations. So most organizations, if they're already established, don't just move everything to the cloud right away. They're still going to have on-prem infrastructure, and they're going to have some things in the cloud when it makes sense. Because the cloud is an operational expense, some things are cheaper to run in the cloud. It's also way more scalable and elastic. So what we mean by that is, if we know we're going to have peak seasons, so all these like cloud trainers always use like a pizza shop as an example. So when we're going to go kill someone, what happens around DC? What spikes? Pizza shop, Papa John's, right? So the analogy is pretty much like if I only have on-prem infrastructure, like your guys' little racks over there, it's set. What is in there is what is in there. And if you are not suspecting or anticipating all of a sudden an increase of like 10,000 users, how are you going to increase your hardware over there? You have to get a guy out there, rack it, configure it, cable it, and hope it gets into the network okay with no issues, right? So by then your peak is probably over. The customer's like, never mind, fuck it, it's not available. So with the cloud is we can make things highly elastic where we can have a trigger points that immediately build new compute, storage resources to anticipate that big spike in like customer usage or data, okay? So why does this matter? We're talking hybrid considerations. Sometimes you scale from here out to the cloud because of that reason. So maybe I have an on-prem infrastructure and I'm like, hey, I know I'm going to have to scale up quickly. So instead of me buying new hardware in anticipation and maybe that hardware just sits there until my spike, I move that to the cloud where I can automatically build my infrastructure. And when that spike is over, I can tear it down. And I'm only going to get charged for what I used in that moment. So it's called operational expense. Okay, third-party vendors. We've touched on this a lot. If you're going through a third-party vendor, look at their SLAs, look at their MOUs, look at their AUPs. Well, let me describe those acronyms. SLA, service level agreement. So that's like, look at what they're actually offering you, okay? MOUs, a memorandum of understanding. So usually you sign up for the cloud, if you're just an individual user, you're not gonna get that deep. But sometimes clouds have what's called enterprise offerings where they give you like more support. So look at that MOU between you and that cloud provider. And then AUP, acceptable use policy, look at what you can and can't do on their infrastructure. You guys, has anyone been hired recently here at L3? Do you even remember your onboarding process at all? Yeah. So at some point, you signed an AUP or something that said, don't fucking hack our computers or something like that, more than likely.
I didn't get onboarding.
Well, sometimes that happens. I didn't either. Because I quit a job, went to Andrew, and then went back to that same job. They were just like, I literally just had to email them like, can you send me my healthcare stuff enrollment? They're like, oh yeah, sorry about that. No, so it happens.
When we got in, like the guy who was doing the onboarding, he quit. So like
yeah.
Like we got left in the middle of nothing.
Dude, that's how it happens. When I onboarded at Andrew, they send everybody to their office in Costa Mesa, and for 3 days you're in auditoriums, like just doing onboarding shit, like learning all it was crazy. Like, I love it. It's near Newport. You know, growing up in Phoenix, that's where we'd go vacation and stuff and visit. So I thought it was sick. I love it there.
I've been on their website just looking at jobs.
Oh yeah, looking at jobs, huh?
Yeah. We're training, you know.
Yeah.
Jason went there, and we're like, okay.
Dude, Andrew is a sick place to work. It just wasn't where I went wasn't a fit for me. But if they gave me any other job there, I would have stayed.
Damn.
Yeah, because I applied for a network architect role, and then they gave it to some dude that's been doing it for like 27 years, and I was like, okay, I get it. And then they're like, we think you'll be a good salesman. I'm like, I don't know why the fuck y'all thought that. Like, I don't know what made you think that at all, but I'm like, I was like, I was very nerdy in my interviews. Like, I don't know what y'all are talking about, but anyways. All right, infrastructure as code. So this is a process, it's very common nowadays, where instead of looking at our infrastructure, think of the hardware, think of the servers, the routers, the switches. Instead of looking at it as individual pieces we need to go individually configure in the CLI or the GUI, we look at it as an entire piece of code where I can spin up a script, Terraform, Ansible, all these coding languages, and I configure all these devices at once. So imagine all those data center racks you guys got back there. We cable them up, power them up, and I have a single device here that runs a Python or Ansible script that can go and configure all those routers and switches at once. That's infrastructure as code. And it's the primary way we honestly, in a big enterprise, large organization, manage the cloud. We usually are not going into the console like you guys saw me doing. Like if I need to provision something, I'm going to create a script that can deploy that application, that VM across all these different cloud regions at once. So it enables consistent, repeatable environment setups. Okay, serverless. I love talking about this one because I hate the name, but I understand from a marketing standpoint why they do it. Okay, so I've talked about web architecture a lot. There's a database, a backend, and a front end. And I say all that goes on a server. And that server is running Linux. That's the operating system. Then you deploy your code, your database, your front end, back end code to it. So your web server sits, or your web application sits on a web server, right? Makes sense? So the cloud is now telling you, hey, you can create your code, code it up on your laptop, and deploy that code to our serverless architecture. So what is that really saying there? What does that really mean? Is that you as a developer can create code, send it to the cloud, and then you don't have to worry about any of that shit underneath. You don't have to worry about an operating system, a server, patches, updates to the operating system, or none of that shit. And they call it serverless architecture. So essentially, you're renting that server from the cloud, but to you it's serverless because you don't have to do any of that management of any of that underneath operating system to run your code. That's all serverless architecture means. Now, from your perspective, if you're like a cloud engineer protecting that serverless architecture, there's something in there called microservices. Those microservices are the databases, the API front ends, and the networking like points that you have to manage if you're working in the cloud. From a customer perspective, if I'm just deploying code, this is a good deal for me because it's probably cheaper and I don't have to worry about any of the patching or operating system or any of that shit. It's how we run our code. Like I don't manage the server that runs Trepatech or Academy.Trepatech. We use a company called Vercel, and we literally just tie that to our GitHub repo. We deploy the app, and it does all the underneath building for us. It just charges us like $30 a month, so it's not bad. Okay, microservices, yeah. All right, talking about some network infrastructure. Physical isolation and air-gapped. So physical isolation is physically separating networks. Air-gap is completely isolating a network from the internet and other networks, period. So we talked about this. Where do you see this a lot? In our CCTV systems and in our OT environments. Remember, OT is like factories, utilities, pipelines, shit like that, where the things that run that factory, those robots, whatever it is, we want to completely segment them from the internet. So we want to air gap them. I think we talk about that more in depth in this domain. So, okay, then logical segmentation, that's like using VLANs, like I talked about already, where we have a VLAN that's tied to a subnet that you tie to a department, and then you can apply security policy to that department. And then this also helps prevent lateral movement. Okay, software-defined networking. I'm gonna try to relate this to you guys. All right, do you guys ever have to console into a router and switch and do some command line? Okay, yeah, I know we talked about it yesterday. Okay, so when you're doing that, that is called traditional networking, where you get a computer, you open up PuTTY, Secure CRT, whatever the fuck y'all use. You console in using that blue rollover cable, or like a USB micro is what it is now.
Yeah.
It's not a C. You console in there, you do enable, config T, and you start going to town, right, with the config. You guys probably get like a baseline given to you, right?
Yes.
Okay. You have to do that at an individual level. So if we were to go configure those switches in your warehouse, we'd have to console into each single one at a time, configure them, correct?
You want to?
I can.
I got a couple that need to.
Yeah, we can do it. That's my day job. SDN centralizes all that. And what I mean by that is if I have 100 switches and 100 routers hooked up to my network, SDN is going to deploy a centralized server or service that's going to give me a GUI, like a web access GUI, where I can push down configuration to all those devices at once. So instead of me individually consoling in and configuring, I do it from what's called a single pane of glass. So software-defined networking gives us a centralized server or service that allows us to configure all of our network devices at once. This can include initial configuration, updates, patches, and policy-based routing. So, if you're like putting in ACLs, routing protocols, whatever you do, right? So it's centralized security policy enforcement from the cyber perspective. You deploy this in an enterprise. The network team is going to do a lot of the day-to-day, but from a security perspective, that is now the one single place that we have to protect all of our network, right? Because that kind of increases our attack surface. If someone gets access to that, they have access to all of our downstream, what we call fabric infrastructure of our access points, switches, routers. Okay, so that is software-defined networking. This is pretty much like I'm not even call it the future, that's like the now. Like if you go on a job board like Indeed and you look up network engineer, they're going to expect you to know SDN. So they're going to expect you to know the protocols and everything underneath that builds SDN, and then they're going to expect you to know the platform. So like Cisco is called Catalyst Center or SD-WAN. Palo Alto has been SDN, like Fortinet, these other big, like Juniper has used SDN for a while now, where you control their shit not in a command line, but from a web GUI. Okay. So yeah, let's do our quiz now. Domain 3.1.1. What the fuck is that? Dang it. Okay.
Yes, I did. I did that.
Did that?
It's really good. It's really good at making questions now too. No, let me finish mine. Hold on. Share responsibility. All right, let's continue. So now it's just part 2 of this, just more infrastructure concepts. Okay, so on-prem, kind of already talked about this, but this is infrastructure and applications hosted within an organization's physical facilities. This is just anything that is in your compound, in your office that you have to manage. That is what we consider on-prem. Then the cloud, talked about this a lot. That's a third-party provider. So here's the top 10 cloud providers. If you're ever looking for a career in the cloud, this one is probably the best to learn, AWS, because so many companies, like private sector, use AWS. And then in the DoD, it's kind of a mixture, but Azure's used a lot because of the IAM, because the Identity Access Management, the Office 365 portal. And then Google Cloud, I think some people use it. I use it, but I'm not hiring. But I think some enterprises use it. But AWS is the big one. It was kind of like the first major cloud provider to come out. Okay, centralized versus decentralized systems. Now this is just an overarching thing. So when the internet was invented, it was meant to kind of be like a decentralized platform with a bunch of nodes all over the world that could authenticate to each other, if they even thought about authentication back in the day. And then as as the internet grew, it became more centralized, where we had these individual identity providers, these hyperscalers, DNS services and providers that were like single companies that would provide a lot of these internet infrastructure services to the entire world. So where we live in now is more of like a centralized system, where everyone's like DNS server could be Google or Cloudflare. That's a centralized system. I use Gmail to sign into so much shit. Websites have that third-party integration and that trust with Google, and so I use my Google account to sign in everywhere. That's a centralized system because that's a centralized identity provider. The biggest example of in our world of a decentralized system is actually the blockchain. Is anyone into crypto here? I'm not like big into it, but if you understand it, that's a decentralized system. The blockchain is literally just millions of nodes verifying each other. That's what it is. Okay, virtualization. This is a concept that's been around a while. So this is taking a single platform, single computer, single server, putting what's called a hypervisor engine on it. That hypervisor engine is then going to allow you to build multiple virtual machines on one appliance or one piece of hardware. So imagine a single rack server. I put a virtualized hypervisor engine on there, just like software like ESXi, Proxmox, and then that hypervisor engine allows me to build multiple virtual machines. So I could have 4 computers in that one machine, or 4 Windows Server operating systems. I can show you guys an example of what that looks like. So there's 2 types of hypervisors. So type 1 hypervisor is going to sit bare metal. And what I mean by that is I have my server. I'm just installing the hypervisor on it. There is no host operating system. That's a type 1. Type 2 is what you see here. So this is VMware Player, if you guys have ever seen it. And this sits on top of my Mac OS. So this is a hypervisor engine that sits on top of my operating system. And then I can just deploy virtual machines here. So I'll show you. One sec. All right. But this is my Linux box. So I'm running a machine within a machine. But I need this hypervisor engine to allocate the CPU, the RAM, the network resources, and the storage resources to this device. Okay, let me get off of this because it takes up a lot of power and shit. You guys use that in your racks and stuff? Yeah. It's very common, yeah. Yeah, it's very common. Like pretty much every single data center virtualizes shit. There's hardly ever a case where you buy a single like hardware appliance like a server and you're not virtualizing it at some level. All right, this is like the next iteration of virtualization, something called containerization, containers. So let me try to break down the difference. So what you guys just saw was me spinning up an entire operating system, right? Okay, now when we talk about enterprise infrastructure, a typical enterprise needs a few key services. You may need like DHCP, you may need like a print server, you need a file server, so that's like your shared drives, and then any other third-party application you may need as well. Now, obviously, a lot of that stuff like the email services is like Office 365 now, so it's like in the cloud. But you need all these servers and services, okay, just to run an enterprise. So if I'm deploying a print server on like Windows Server 2025, that's the operating system, it's supposed to be a 1-to-1 ratio. So what I mean by that is a server, a virtual machine, and then the service. So in that case, it would be a Windows Server virtual machine, and then the print server service running on it. And then that's it. That's supposed to be the only thing running on that VM. Okay, now do you think we should just have one or should we have two? Probably want two because you want redundancy in case that one goes down. So then I get another server because you don't want to put it on the same physical hardware. Get that server. I probably cluster them together. I deploy another VM, and then I deploy another print server on top of that, or service, and then they're like replicating, or they're in a high availability pair. One's active, one's passive, okay? And you do that for every single service you need on your enterprise. Because you don't want to put like DNS and DHCP on one server for obvious reasons, right? Because then they both go down if that server goes down and that virtual machine goes down, okay? So that takes up a lot of compute resources. If I need a VM per service, and I have like 100 services I need to run, that's 100 VMs I need to manage. Essentially, that means 100 computers I need to manage and patch and update and vulnerability scan and put endpoint detection on. You guys see where I'm going with this? Okay. It's not that it's hard to scale, it's just a lot to scale. And then if I have that many services and servers and virtual machines, I probably need more than just one system admin. Probably need a senior, probably need a mid-range and a couple of juniors. You know, it starts really scaling out and it starts costing your organization a lot of money to run these services. Containerization is the next level of this, where instead of having a 1-to-1 ratio of VM to service, all we have here is a single server running Linux. We install what's called the container engine, similar to the hypervisor engine, and instead of us needing to deploy a VM, we just download this container. You see that? We just download a container that's going to contain all the dependencies and then run our application for us. So it's not a whole operating system we need to patch and manage anymore. Essentially, our security is at this level. And then obviously, if this is like hosting DNS or something, people are going to connect to this container. So you got to connect or protect the network connection you may have there. But the container engine and host operating system is now our attack surface instead of 100 other VMs. Okay. That makes sense, guys? It's more lightweight and it's more rapid. If I have to deploy Windows Server 2025 in a VM, has anyone done that before? It takes like an hour, right? Even if I script it, it has to install, provision the storage, get its updates, and then I probably have like an image baseline. I'm doing more shit. It takes like an hour. A container, you'll have a centralized container repo, either on-prem or you just use the one that everyone uses called Docker. and you can download it and run a container within like 30 seconds. It's literally that easy. You go on your Linux like command line, you access the Docker container engine, and it's literally like install container, you give the container name, and it deploys it within like a minute. And then your web application, let's say that's what you're deploying, you just put the code on there, and that's it. So it's really quick and rapid, okay? That's containerization. So, cybersecurity though, right? Our attack surface is now just this container engine itself and the host operating system. And our container images, yes, they can be exploited. Someone could like attack that network, denial of service, things like that. The answer for like protecting containers is always two things. Ready? Redeploy a new one if one is fucked up, because that's how quick it is. Or two, make sure you're downloading containers from a valid source. That's always going to be the answers on these tests when protecting containers, okay? Download from a valid source or just redeploy it. Make sense, guys? Okay. All right, IoT. I've talked about this, Internet of Things. These are just all those little like embedded devices and shit that connect to the internet. So you see, like washer, microwave. Anyone got a Wi-Fi microwave?
Not yet.
Yeah, want to talk to it right now?
Yeah, heat something up right now.
I gotta wash my dryer.
Give me some of my voice.
All right, so this is finally getting into OT, the operational technology. So when we talk about OT environment, there's going to be two major like architectures. ICS, which really is just like a umbrella term to say industrial control system. So that's, hey, what type of ICS you're running in your dam, in your factory, and your power plant. And then SCADA is actually the way we do architecture in an OT environment. It's called supervisory control and data acquisition systems. Here's the language they use. So you see this guy here monitoring all that shit? They would call that an HMI, a human machine interface. Okay? And then down below, you're going to have like sensors, things like that. We don't need to get into architecture. And something called PLCs, programmable logic controllers, which guess what that is? The computers that give configuration to the sensors and the shit that's going on inside that factory. They just have their own little language for it. A real-time operating system, an RTOS. This is designed to serve real-time application, process data as it comes in. Okay, we'll move on. That's just a mini computer, really is what that's saying. Embedded systems. These are computer systems with a dedicated function within a larger mechanical or electrical system. When we look at this from a cybersecurity perspective, it's really hard to secure because they're just purpose-built little mini operating systems that really shouldn't have that big of an attack surface in the first place. So if you have these embedded systems, from an architecture's perspective, we like to segment, put them in their own, like, not isolated, but siloed networks. Okay, high availability. So we talked about this. This is, you're designing a system for failure, essentially. Like, we understand it's going to fail. The primary server may fail. So we need a backup. We need something that's highly available. So for our most mission-critical applications or assets, it's always like 1 is none, 2 is 1, right? We want physical, logical diversity, things like that. So what I mean by physical, logical diversity is that if I have two databases that are replicating, one's primary and one's the alternate, in the same data center with the same ISP hop, is that really redundant? No. Because this could fail, like this database could fail and this one could take over. What if the ISP goes down and they're both using that same connection? Are we redundant? No. If there's a power outage at the data center they're both at, are we redundant? No. So you always want what's called physical and logical diversity. So if you're on a huge, like a base, for example, like an army base, this is just what I know. When we set up our circuits out to DISA or ISP, we make sure that we use 2 different fiber paths on that base and that we go to 2 different DISA provider edge routers. So if this provider edge router goes down, we actually do have redundancy from our router here. Make sense? Physical, logical diversity. And we try our best to make sure a completely different fiber path as well. No, why? Because if we're downrange and a fiber fucking patch gets blown up, we want to use that other one, which literally just happened. You guys remember when Iran shot rockets into Qatar?
Yeah.
It actually hit, well, I don't know if it was debris, but the data center I used to work at in Qatar literally got destroyed. Like the antenna pad and everything got destroyed. So still on our like monitoring board at my day job, we're still yellow on a site because they haven't fixed it yet. So we only have like one link coming out of there. But it kind of proved like, oh, we're good. Like we are redundant. If one got blown up, we could use the other path.
So now that's the standard.
It's pretty standard for like any place that has like the money to do high availability and things like that.
Cash money.
Yeah.
I had to actually do that back in Rochester.
Yeah.
Run the two paths.
Yeah, it's because that's why. Because it's like you think you're redundant if you have two servers, but there's a lot more that goes into it.
Go, go, go.
Okay, let's finish up domain 3.1, then we'll take our first break. So now we're gonna go over considerations when building infrastructure. So resilience. So how resilient is our infrastructure, is our architecture? It's kind of in the same vein of high availability, or high availability sometimes is like a technical term to describe how you set up like firewalls or like wireless LAN controllers. Resilience just kind of high level, like, hey, are you prepped? Did it go into your design the risk of failure or your continuity of operations? When you did your business continuity planning, did you plan for resilience in there? So how do we test our resilience? So there's different ways we can do it. We have like tabletop exercises, simulations, where we actually do fail. We're like, hey, let's shut down our primary, see if our secondary takes over. And do we have some way to dynamically adapt? This is more of like a concept in the cloud where we can like switch things over to a different region or different availability zones within that cloud. But it, here it says systems should be designed to dynamically adapt to changing conditions. That's a big should there because that takes a lot of resources, expertise to dynamically like coop over to like if your primary fails. Okay, cost. This is the big one. This is what organizations actually care about. Okay, yeah, we need to be redundant. We need to have resiliency. But what's the cost? If I build a data center here, it costs me $1 million, and you tell me I need to build a secondary data center in case this one fails, the first question is, well, why would this one fail? That like management always comes up with. Then you got to explain to them like, hey, sometimes there's things out of our control, like the power grid is out of your control, natural disasters are out of your control, and if sometimes you may have to put it in like a quantitative, like if this data center goes down due to a natural disaster, here's how much money you're going to lose. So sometimes that can be like a reason to build that redundancy. Then you have to just consider the long-term costs and savings. Responsiveness. So this is the ability of a system to respond and adapt quickly to changes. A lot of times in our cybersecurity infrastructure, we have a SIEM. We also have something called a SOAR. It's a security, orchestration, automation, remediation. So a lot of acronyms to say, hey, do we have a system that can detect something malicious, detect a breach, detect an exploit without human intervention, and then can we run a playbook against that to remediate that? So whether that's isolating an environment without human intervention. Scalability. This is the capacity of a system to handle growth. So there's two types of scalability. There's vertical and horizontal scalability. Vertical scalability is, imagine you buy just a real big beefy server that has, I don't know, like a petabyte of storage, 512 gigs of RAM, or maybe a terabyte of RAM, these AI data centers nowadays, and a fuck ton of CPU, okay? And you deploy services on there that only use like a quarter of that. So you're not using all the compute and storage resources that are possible in that single device. And then all of a sudden you have an influx of users, you have a spike. Now you can go and provision on that single node more of your compute and RAM and storage resources. That's vertical scalability. Taking a single computer, server, and scaling up its resources, okay? Horizontal scaling is kind of what you see here. Well, instead of like building this single node, we start to build more nodes and then we pool them or cluster all the resources together, which is a very common way we do it in the cloud or with containers. So, I just taught you guys about containers. They're lightweight. If we are running a web application on a container and we see a lot of users, we want to put a load balancer, things like that, and add more containers. In the cloud, we have orchestration tools. Well, it's not just in the cloud, it's on-prem too. Like Kubernetes, we have these additional tools that can orchestrate those containers to scale out rapidly. So instead of us, putting more resource on a single one, we just build more, pull them together, put them in the same network, and they all work together in a cluster. Okay, ease of deployment. This is probably something you guys think about, right? When you're building your racks, like how is this actually going to go into our whatever area? But the simplicity and speed with which new systems, updates, or patches can be implemented, just something you have to think about. The ease of deployment. Okay, now getting more into like cybersecurity risk. So we know there's going to be risk management in our organizations. There's going to be a risk tolerance and a risk appetite from the top down. And what we mean by that is we're going to have management that says, hey, I understand you're telling us we could be data breached. There's these vulnerabilities that are potentially could be breached. And you're giving me a cost of how you need to patch it. You need 200 grand to your department to fix these things. Well, let's say I have a high risk appetite. So I don't care. I'm like, hey, you're saying this could happen. Well, I don't care if it does happen. I don't think it is. I don't want to spend the money for it. So instead, if you have like a high risk appetite, what a company will do is something called risk transference. It's just insurance. It's like cybersecurity insurance, where you pretty much just say, hey, if we get data breached, this insurance company is going to pay out all of our financial losses, and like we're going to explain to them the reputation loss and how because this data breach, we lost this much money this quarter, and that cybersecurity insurance is supposed to pay you that difference, okay? So risk transference is pretty much cybersecurity insurance. So you see that on the test, right? Ease of recovery. This is the ability of a system to recover quickly from a security incident. So you learn this through exercises. Your incident response team should be running quarterly, monthly exercises through simulation, maybe in a sandbox or just tabletop exercises, where you like understand, hey, if this server gets ransomware on it, I do full backups every Sunday. We have a persistent state that we take every day, nightly. So I know I can recover very easily from ransomware. Now, if there's an APT doing data exfiltration and we haven't discovered that APT and they're on like a printer or something like that, how easily can we recover our entire enterprise and find out where our PII went, or that sensitive data? That may take a long time, so it's not a quick, easy recovery there. Okay, patch availability. So this is just saying, hey, make sure you're patching, okay, regularly and make sure it's highly available. Inability to patch. When would we have a system that we can't patch? You guys know what that's called? Legacy. Yeah, old as shit, right? Legacy. That's when we don't have the ability to patch. So we have a couple options. Compensating controls, or eventually you got to update it, okay? We've talked about that a lot. Okay, something that is missed, like, especially like me, like I get so nerdy with like the automation, the building of resources, deploying servers. Something that it sometimes is missed is like the power requirements of something. So when I'm going to vendors and I'm purchasing new servers and I know what data center I'm going to put them in, typically we work with like a third party to be like, hey, look at these power specs for these servers. Is that going to work in our data center? And if they're like, yes, no, or yes, it'll work, but you won't have much left over. It's just something you have to think about when deploying big systems like this. Or if you're doing shit at the edge, power is a huge concern, right? Because maybe you don't have a good power coming into that edge wherever you're at. So you have rolling brownouts and you need to mitigate that. So maybe you put a generator there, like an ATS switch, or you have what's called an UPS on all your systems to help with those rolling brownouts or even complete blackouts. And then compute requirements. There's just saying, hey, what are we trying to do? Are we trying to install an AI agent in our network? Then we need something that's GPU heavy. So that's a compute requirement you have to understand. All right, let's do our quiz. Then we'll take a 10-minute break before we go to domain 3.2. I saw. Yeah, yeah. Oh no, all good. Those questions get asked by every corporate company I work with. Online though, just to answer it, I'll put it in an email. But those virtual trainings are like after hours, and it's only 3 hours of training, 3 days a week. So that's why the cost is a little less. But when we do these 5-day boot camps, I pretty much have to pay an instructor those full 5 days, like 9 to 5. That's why they increase in per cost.
For in person?
That was virtual.
Virtual.
The in-person one's a little bit more expensive. Yeah.
Yeah, I just tell them to swipe a fucking card.
That's all. No, dude. Every company I work with asks the same thing. Don't worry. I think that's pretty standard HR or like approval process questions, at least from what I've seen.
This is the one that accepts our expense reports, right? She's not approving this fucking shit for the, on P-card.
Maybe hit her with a Teams message and be like, hey, I don't know if you know this, but I have a P-card.
Yeah.
She put a meeting out for Monday to go over expense, the primary things, expense reports, time cards, and
Open forum.
open form, yeah.
Yeah.
So she's probably gonna talk about that.
Oh, she's horrible at expense reports. Irritates the living shit out of me.
She just be approving my shit.
With the travel shit, yeah, but this is, I had to switch her over to my approver, cause I hadn't used it in a while.
Click it back to Rodney.
Yeah, right?
Yeah.
Nah, he doesn't even pop up, it's either her or Lance.
Old caller.
Not doing good today at all.
Going on the quizzes? I knew today was gonna be harder when I went over some of those, like exam ones, the stuff I didn't know, I was like, oh, this shit seems way harder than the stuff we learned already.
It's not too bad.
So when we save, like when we review the quiz questions, right? When we save and exit, it saves the answers and everything.
Yeah.
Alright.
Yes. I think that's what you're asking. Like if you exit it, yeah, yeah.
Not only that, but now I know how to do, now I know how to do,
And you using it? You see, it's giving us, give you the answer. It's give you like, you know what I mean?
Oh,
I just want the, give me the answer.
That's not how it works, man.
Come on, why not? Yeah, I'm using ChatGPT 5.1. So like,
You gotta use 5.2, otherwise it's not gonna work.
yeah.
6.9.
I think they have a new, like 4.20 or something. Gotta help
this on my personal phone.
That's the way it- It's gonna show all the questions to my wife.
Now, I'm gonna test it. Oh, it's testing things. Alright, so I change in ChatGPT, I change it to precise. You know what I mean? So this is what it does. When I change it to precise, it just gives me that. I don't have to run through everything. Trying to-
Yeah, I just asked, the 3 guys that I have over at St. Mary's, they have absolutely zero clue on Workday or any of that stuff, so,
Outstanding.
thank you.
Meeting?
Mhm.
Oh, so put that one.
What's up with that one?
Unknown caller.
They turn it up a
Oh,
little bit?
that's a spam.
Hello? Hey, put it on speaker.
Yep. Good thought.
You man over here.
Alright, love you, Mom.
Put a woman on, please.
Somebody
Can
that
you put a
see
woman
you.
on, please?
Mom.
Can you put a man on, please?
Ah, Mom. Take one for the team. Make her not her anymore.
Man, I haven't dealt with her. I haven't talked to her yet.
Is that your finance lady or something?
No,
No,
she's
it's
our
our
new manager.
Oh,
Like everything about her in the initial meeting
Oh, Lord.
screams,
Problem.
my name is Karen.
mm.
You will respect me.
Oh.
How'd she get the job?
What's that?
How'd she get the job?
I don't want to talk about that.
Nepotism
Well, I talked to, so Blake.
happens a
I
lot.
was good buddy. I'm good buddies with Blake. I still am. I used to fly drones with him and everything else like that. He used to be our manager, and he explained exactly why she got the job. And I was
Damn.
like, oh, okay.
Happens a lot.
Yeah.
My boss is like that. My
So she's
initial.
from L3 Harris,
Of course.
but everywhere
She has been.
has been dissolved.
Oh God.
Oh,
That's scary, bro, for
Yeah,
you guys.
So like, and essentially, she got this because she. I didn't say it, but yeah, because it was supposed to be Cliff, right? It was supposed to be Cliff or Joe, but Cliff is a contractor, and Joe went under. Who's the guy with Blake?
Rodney.
Yeah, there you go. He went back under Rodney under East Coast stuff. So
You guys wanna watch police chases?
Reno.
there it is, dude. I'm watching those too.
All right, guys. Let's finish up domain 3.2 and then we'll go to lunch. So domain 3.2, given a scenario, apply security principles to secure enterprise infrastructure. So more infrastructure considerations. This is going to go over a lot, like where do we place things so that we get that high availability and we get that scalability and we get that resilience. So device placement. Up here on the screen, I have like a Wi-Fi heat map. It's just a great example because when you're deploying a Wi-Fi network or wireless local area network, Wi-Fi, and you're in a multiple story office building, what do you have to worry about? You guys work with RF a lot. 802.11 Wi-Fi signals is really just RF. A lot of overlap, channel degradation or channel overlap. And you want to make sure you have the right antennas, the right omnidirectional antennas to get the best signal throughout that office space. So even with Wi-Fi, if you guys have ever done it like on a large scale, it's actually pretty fun. It's a lot of RF, really. And seeing what antennas work best, seeing how the channels don't interrupt each other. But device placement, very important. Security zones. So I put on there a man trap because this could be in the physical world or this could be logical. Security zones are segments within a network where specific security policies and access controls are applied. How do we isolate or do segmentation in a traditional network environment? We use VLANs. When we're doing it in a cloud environment and we have those microservices, guess what we call the segmentation there? Micro-segmentation. And that's where we apply security policies on a per resource basis rather than like an entire network. And then in the physical world, we have controlled access points or ECPs. You guys ever heard that term? Entry control points. Okay, attack surface. Talked about this a lot, but in our entire enterprise, we have resources in the cloud. We have remote workers. We have multiple on-prem sites. Maybe you have a bunch of spoke offices. You have an HQ. Maybe you have a public web portal. Maybe you have an employee portal that's part public and part internal. All that data, all your resources, that is your attack surface. So when we look at the attack surface, that is the sum of the different points, attack vectors, where a user or an attacker can try to exploit you. That's the attack surface. So what are we talking about here when it comes to infrastructure considerations? From a cybersecurity perspective, we're worried about confidentiality, integrity, and availability. So when we're building public resources, that's what I'm going to use because you think of an attack surface, you want to at least stop the external actors and then do what you can about the insider threats. But from an external actor and from a cybersecurity perspective, if we have to have public-facing web servers, we want to try our hardest to reduce that attack surface. Now, how do we do that? With hardening, disabling unused ports and protocols, and just having that good defense in-depth approach. If we have remote workers or an employee portal, so we want a good VPN that probably has some sort of contextual awareness, conditional access, and multi-factor authentication. Same with the employee portal. Like I just signed in to do my time card. I got an email from my boss saying, hey, do that shit. And I have to log in with my Office 365 identity, and then I have to go to my authenticator app, get a code, put in that code, and then I get access to my portal, right? It's a big pain in the ass. But our attack surface is the sum of all of our parts. We do our best to harden it and limit it while still keeping systems highly available. And we want to do continuous monitoring of our enterprise. So we know what our attack surface is, where our trust boundaries and our touch points are on it. Okay, connectivity. I honestly hate that this is an exam objective because it's so broad. All this is saying here is, as a cybersecurity analyst, you need to be part of the conversations in ensuring the network can be connected to all of our users. That's it, okay? Let's move on. Okay, failure modes. So when a system fails, how is it gonna do it? And what we mean by that is when we set it up, is it gonna be a fail open or a fail closed type of system? So a fail open scenario is we have system failure, whatever that may be. That could be an exploit. It could just be like you applied a patch that actually wasn't good from the vendor. You didn't test it in your sandbox first, so it brought the system down. Well, in a fail open scenario, it defaults to allowing everything in. So all that hardening, all that access control, all that whitelisting, all those permissions you set in a fail open scenario just goes away, okay? So why would we want this? We want this if availability and keeping operations, alive is your number one priority, right? So like in the DoD and the government, this is always a hard thing because we're so sometimes strangled by cybersecurity, information assurance. We can't deploy certain applications. We can't do the things we want. But if we're on a mission, we're on the X or whatever you want to call it, you don't want cybersecurity to get in the way of having good data and having good timely information, right? So there's always kind of this tit for tat thing. So some systems are built like this, where it's no, if cybersecurity can't be applied correctly or there's a failure, we want it just to work, okay? Leave the system available. Then we have fail close. So this is where the system shuts down in the event of a failure or a malfunction, okay? And this is obviously our cybersecurity focused failure option. If we're worried about our security first, we do a fail close. Okay, device attributes. So this is something that you manually assign. So if I'm in an Active Directory domain, I got printers, I got laptops, I got desktops, I got servers. Where are we at? Domain 3.2.1. Here we go. Let's do this quiz. Yeah, just kind of going over that point again where this shit kind of gets redundant. How many times have we talked about like hardening? Probably every single day, right? Yeah. It's like CompTIA tries to stretch out things, like just to make their tests longer. That's what it feels like sometimes.
Well, they definitely try to trick you on those questions.
Yeah, they do. That's why, I don't know, it was a trainer. He's a popular trainer for CISSP, just another cyber cert. And he says like, he's trained like lawyers and stuff to get these cyber certs and that they always pass better than his like IT students.
You gotta take them tests.
It's just like comprehension, you know what I mean? They read so much, yeah.
Yeah, there was some last night where I was like, I fucking knew that, but I didn't
Yeah.
read it correctly.
A lot of like my students that purchase self-paced that are non-English speakers, I'm always impressed because I'm like, because they don't offer it in every language, you know? And they have to take that shit in their second language. That's hard.
How come they don't do it in patois?
Yeah, well, it's fucked up. You know, in like Cisco, it's only English or Japanese. That's it.
Damn.
I think CompTIA, they'll do like Spanish, English, Japanese, and I think like Mandarin, and that's it.
All right, misunderstood. Drop.
That's never gonna happen.
We had 3.3.
I'll take an Obi-Wan as well. That shit was fucking dope too.
The one season of that was so
Yeah.
good.
Yeah, it's like if I had to
Private data.
Show someone that
sensitive data.
didn't watch the shows but liked the movies, I think I'd show Obi-Wan.
122.
What'd you guys choose for this question up on the screen? B or D?
I'm
I'm doing that one right now.
Wait.
It's confusing, huh?
I initially did D, I think.
Yeah, no, I would be.
Think it's B?
See? Why
Yeah.
not it's B, but
Yeah.
I did E.
Because it's like, D's right though. D is like the passive device is that, but I think it's saying being really specific. Because passive device doesn't necessarily mean network. It can be like your systems, cloud, you know.
No, once I went back and oh, okay, see, well, yeah, that explains it right there. Oh, okay.
Yeah, it's like network specific.
Yeah, and that's funny. Usually in the question is that keyword.
That one word.
Yeah, and once you see that keyword, that's the equivalent.
Yep.
Oh,
Yep.
shit.
I was noticing that last night. In fact, that was
Continuous operation.
tonight's like you
Fail
said, I was
close,
gonna
yeah.
do Keyword answer.
That's how it is. Like the popular trainers online, they say that when they go through their question dumps, or not dumps, banks, they say the same thing. They're like, eliminate two, and then find the keyword that makes more sense for these two very related answers.
That was a good example right there.
Yeah.
They do have some easy ones where you read something and you're like, oh.
They have softballs, yeah, where it's like,
But then you're like, is it?
Yeah.
you second guess yourself. Yeah,
You watch
yeah.
it and you see the right answer. you're
Well,
like,
that's why people that don't do IT or this kind of shit daily, I'm always impressed when they pass because I'm like, I don't know how you can memorize every single acronym. Like I work with this shit daily, so it comes up.
I
But
kind of wish they didn't fucking abbreviate everything. 'cause
Yeah,
it's
no.
A lot harder.
What?
Just all the fucking
Well, some of those
acronyms
questions,
and
do
abbreviations.
you know your acronyms?
Yeah,
Like,
yeah.
A list of.
It used to be bad, bro. Like back in the day, 401 was like they made you memorize port numbers.
Oh, yeah.
Yeah, they don't do that no more.
5.
Yeah, 501.
501 is like that.
They changed though. It hasn't been like that in a while.
601.
I'm glad because it's stupid. It's like you just test me on memorization. Okay, that's yeah.
Do you know your dates? and
Yeah,
history?
that's like they probably they're just lazy. Like the people writing the exams are like, all right, this is a okay, guys. Now we're gonna go over network appliances in domain 3.2. This one I try not to be too long-winded because this is like what I do on a daily. So network appliances are just the devices that sit in your network that are responsible for getting the packet from point A to destination B. We're gonna go over all of them and their specific purpose and how we harden or secure them. Okay, a jump server. So this acts like a man in the middle, so you can access segmented or like logically or physically segmented network. So common example of this is, let's say you have an ICS environment. You guys remember what ICS is? Industrial Control Systems. So OT, not IT. Then a data center would be IT, your regular information technology. So imagine we have to manage both of these. Remember I told you, you always want to keep this shit separate. So we see that the ICS and data center, they do have a touch point here at some firewall that's probably just doing like an implicit deny for most of the traffic. So if I want to manage both of these from my home, my remote management system, your computer, right? Instead of allowing direct access there, direct access to both, I have to hit that jump box first. So this is like where I have to go first, log in, authenticate to the jump box, and then from the jump box, I have to authenticate and log into both these systems or environments. So it's just like an extra step in protections and authentications and authorization methods. Very, very common though. Like in the cloud, you can deploy jump boxes and jump servers all around your cloud environment in different regions and zones and different virtual networks. What's the point of it besides just controlled access and authentication? One, it allows you to keep that isolation and segmentation, because if we didn't have this and I had to manage both of these, I'd either have to have two separate networks, two separate laptops, which is common, but if your company's cheap, they're not going to want that. And if I didn't have this, these would have to connect at a different touch point here that could leave it exposed. It also allows auditing and monitoring. So I've worked in an environment where our jump box was where all of our admin tools were. So instead of installing all these admin tools on my local box, I would go to that jump box via remote desktop, and all the admin tools I needed to access my servers, Active Directory, was at that jump box. So it allowed us to see, okay, which admin was doing what on the network, so it helps with auditing and monitoring. Okay, a proxy server. This acts as an intermediary between end users and the internet. So we have two types, a forward proxy and a reverse proxy. They have the same concepts to do the same thing. So see here my private, or my users in this LAN, before they hit the internet, they touch that proxy. So they're going to send their traffic to the proxy. The proxy is going to do something called network address translation, and then that proxy is going to send their traffic out. So when I'm connecting to this web server over here from my user, they're not going to see my IP, they're just going to see this proxy instead. Okay, it's just another kind of like man in the middle. That's a forward one that's going to be client facing, okay? A reverse proxy usually sits at your data center or wherever your web server farm is. This could be in the cloud as well, where these web servers have their private IPs, and when a user connects to my website here, instead of connecting to this 10.112, they actually connect to this 12.332, then the proxy server sends that traffic on, okay? Just another man in the middle, another way to kind of protect and have privacy and mask the IP addresses of my users or my servers. And both these proxies are going to be doing something called network address translation, okay? Where you get it, where pretty much you're translating from these private IPs to this public IP, and you're going to maintain a NAT table there for all your sessions, okay?
Is one safer than the other, or like has more advantage?
It's literally just one is like for your users, one's for your web servers. They do the same thing. Yeah, like this here, like all you guys on the L3 Harris network, if you had a proxy server here, you would hit that. But your HQ, your data center where all your employee portals are, would have a reverse proxy if you wanted a proxy. Yeah, that's the only difference. And then here, some things they do additionally is content filtering. Used to be a very common thing. A lot of these technologies are all wrapped up into like one device now, like your firewall can do this as well. But it used to filter content, so it would deny certain URLs, things like that. It also can do caching. So proxy servers can do more than just their primary purpose here with privacy and anonymity. I think I'm saying that right. Okay, moving on. IPS, IDS. We've talked about this a lot. IPS is prevention. It monitors and prevents attacks. IDS just monitors and just alerts. Okay, moving on. A load balancer. A load balancer is going to distribute incoming network traffic or sessions to your web server farm or to whatever applications you're trying to distribute that load to. So it sits, do I have an image of it? No. So a load balancer is kind of going to sit in front of like your web server farm or wherever your web applications are, and it's going to notice depending on what algorithm it's using, like, hey, I got 4 web servers. They're pulled together and they're all servicing the same customers. If I don't have a load balancer in front, I just have a router, it's not gonna like logically know which sessions are more oversaturated per web server, but a load balancer will. So essentially it just prevents like these denial of service attacks and oversaturation on a specific server or endpoint. So it increases our availability and redundancy on the network. Okay, port security. I think I talked about this yesterday. This is where we control how many MAC addresses can be allowed on the switch per port. So here's the actual configuration on a Cisco IOS XC device. So you see switch port security, maximum 2. So that's saying only 2 MAC addresses are ever allowed on this connection. So if me and you plugged in our computers into this wall jack here, that's it. If you did, it was gonna block that port. It's gonna shut it down, send it into what's called an error disabled mode. And it's all based off MAC addresses, okay? So if I was able to spoof your MAC address, then I'd be okay, which is a possible thing to do. So it's not perfect security, but
So you could spoof with the same MAC address and have
you can.
three
Well,
users
devices, yeah.
With the
It's really easy too, because like MAC addresses used to be called burned-in addresses, which pretty much means my NIC here, my network interface card, from the vendor would get a MAC address, and that's how it uniquely identifies itself on the network. That used to run in hardware. Now it's easy to download a MAC address like emulation tool, and you can change the MAC address of your NIC. So it's really easy to do MAC spoofing now. Yeah.
so port security.
Well, port security works when you use it in conjunction with other things, right?
Yeah.
Because if I have a whitelist that doesn't allow you to download that kind of shit, then it's not a problem.
Yeah, I just
You
mean
know?
like exclusively port security.
Yeah, yeah.
Isn't as good as it used to be because of that.
Right, because there's tools to get around it. So yeah, defense in depth, right, in cybersecurity, you do this and your allow listing, and you make sure that, your users aren't bringing their home computers in, things like that. Okay, 802.1x. This is another network access control protocol that I briefly touched on, but this helps us with authentication. 802.1x, you guys ever signed into Wi-Fi and it's username and password, it's your actual credentials? That's 802.1x in conjunction with a AAA protocol called Radius that essentially is going to verify more than just a MAC address. There could be a certificate on your device, your credentials, and it's going to authenticate you based off that. That's 802.1x. So we use that on our switches and our wireless local LANs to do authentication. Okay, EAP, Extensible Authentication Protocol. This is a framework that supports multiple authentication methods for securing network access and communications. So all this is, just imagine, like I'm going to use that pizza scenario again, where we say, hey, here's the dough, here's the sauce. Now you pick your cheese and your toppings. That's EAP. It's like, hey, we're a protocol that's going to allow you to do any type of authentication you want. So there's different authentication protocols. Radius and TACX could be tunneled through EAP, okay? Let's say you want to add protections on our authentication. Because an authentication process isn't really confidential, right? Authentication is you're presenting a credential or a password, and a server is saying, yes, that's accurate, that's the right password. But is that confidential? Remember, confidential is like encryption, things like that, plain text to ciphertext. So we can add things like TLS onto our authentication process so that if someone's doing a man-in-the-middle attack, it's end-to-end encrypted now. It's just ciphertext, okay? So this allows us to use our authentication protocols like Radius, TACX, and then couple that with encryption, okay? It's an open framework. All right. Firewalls. Let's dive into the different types of firewalls. So a traditional firewall that's old now, it's considered old, used to just filter based off layer 3 and layer 4. Now, I know I didn't go over the layers here because the assumption when you take Sec Plus is that you have some sort of like background in IT and networking and the basics. But essentially, it filters based off IP address and your port number. So when you guys are doing an HTTPS session to trepatech.com, that port number is 443. That's layer 4, okay? So you look at a data packet, you have layers 2, 3, 4, 5, 6, 7. Layers 3 is IP. Layers 4 is ports and protocols. And that's all it used to filter on, okay? So imagine my layer 7 is hypertext transfer protocol, where I'm actually sending or uploading files a firewall couldn't look into that, okay? So we were able to hide malware in that layer 7 data packet. Does that make sense? So a traditional firewall was just filtering based off IPs and ports, saying, hey, we're not going to let you go to port 80 because that's not secure. We're not going to let you go to this destination IP because that's blacklisted. But there's ways around that. So the next step was having stateful or application level gateways. And what we essentially mean there is that we had a firewall now that was able to look into the layer 7 and actually look at your data payload and then allow or deny based off your data payload, not just an IP or a port number. So let me show you a little bit what that looks like. Okay, remember Wireshark, guys? We'll do a packet capture. So I taught you TLS and HTTPS, and that is end-to-end encryption. So what I mean by that is from my computer here, I'm going to pause. So here's TLS, right? I can see the source and destination IP. So that destination IP, where is that going? Let's look it up. NS lookup. And sometimes it doesn't always work because companies have protections on this kind of, like their DNS. Yeah, so I don't know, whatever this is, right? This is like the ISP. I don't know what the fuck that is, but okay. So if I'm a firewall and I want to deny based off that destination IP, I can do that. You see there? It's clear to me the destination IP. It's clear to me the destination port and source port. But now let's say I want to just do data loss prevention. I don't want to deny based off layer 3 here, layer 4. I want to see inside of this packet and be like, hey, what are you actually sending? Are you sending PII? Well, I can't see that here, right? Because it's protected under TLS. Make sense? This is the ciphertext, encrypted application data. So whatever I'm sending via the hypertext transfer protocol, I can't tell. I can't see it. So firewalls had that problem where they're like, we can't see inside the actual fucking packet. So what did they come up with? It's called TLS inspection. So firewalls now that do layer 7 inspection, our next generation firewalls is what we call them, they would actually decrypt this session, okay? They would decrypt it, inspect your packet, and then re-encrypt it and send it off to the internet, okay? So that's how they accomplish that. So that's why when you're going on like your bank, you know, and people are like, oh, people can packet capture. Not really. If you do a packet capture, I'm showing you what it's going to look like.
Yep.
It's just ciphertext. It's encrypted. It's end-to-end encryption when you use HTTPS, okay? I'll show you what regular HTTP looks like here in a second. I'll spin up a VM in my cloud environment. So you can see when you don't have that end-to-end encryption and someone is doing a packet capture, you're fucked. Okay. Back to the slides. I'll show you that in a second. Okay. Web application firewall. Now, this is something specific just for HTTPS sessions. So firewalls, they're permitting and denying everything. DNS traffic, DHCP traffic, SSH, all these different ports and protocols we may use. There's so much going on in enterprise. But a web application firewall, typically going to be like sitting in the cloud as well to protect your web applications in the cloud, are just protecting your HTTP web sessions. That's it. So what are they looking for? Our common web application vulnerabilities and exploits like SQL injection, cross-site scripting, forgery. They're just looking at that HTTP session to see if there's anything malicious going on. Okay, a UTM. It's kind of an old school thing now. They don't really use this in marketing when they're selling a device in cybersecurity. A unified threat management system is just, hey, I have this box, this device here that does all my cybersecurity for me. It does IPS, IDS. It does next generation firewalls. It's a VPN gateway. It does my routing. It does my web security. It's a proxy. It's all these things wrapped into one, okay? Nowadays, like if you go buy a brand new Palo Alto firewall, it's already doing that, right? It's already being able to do VPNs, IDS, IPS, enabling some sort of large learning model to do AI. It's kind of an old school term. Just if you see it on the exam, just know it's something that combines all those security functions into one device. All right, I just went over this, so we don't have to go over it again. All right, let's do our quiz. All right, let me start. I want to show you guys what it looks like when something's not protected. Hold on. All right, so check this out, guys. There's a VM in my cloud environment, and this is what it looks like when it's not protected. So you see there's no TLS session.
Yeah.
But under my hypertext transfer protocol, I get all this information about what I'm sending to and from that web server. So let me find something down here. Hold on. So yeah, you see it shows me exactly where I'm going. And a hacker can pretty much look inside this JSON object and be like, okay, what message are you sending? And all this key data. So that's what it looks like when you're not doing TLS. If someone were to do a packet capture, they could come in here and, look at what you're sending to and from your bank and things like that. But yeah, let me see. And that's why when you look at a TLS session, you don't see HTTP there, It's just TLS. And obviously, we know it is. That's the destination port 443, so we know it's a hypertext transfer protocol, but all that data, now encrypted. Here's what it looks like in plain text. So it's showing me everything about that web server I'm going to. Ubuntu, the API I'm requesting. And if I were to sit here and keep searching, I could pull out a lot of this information and reconstruct it, because this is in JSON format. But yeah, it's a lot of shit. But if we had the time, the patience, and did this capture, we could recreate a lot of this data that's sending back and forth.
Sitting down for hours doing that.
Well, there's scripts though that can just do it for you.
Oh,
Yeah. Okay, now I'm gonna go turn this shit off. All right, do we have time for this last one before lunch? Let's see. How heavy is it? Yeah, we'll be good. Yeah. Okay, let's finish up domain 3.2 now. So now we're going to go over secure communication and a selection of effective controls for our infrastructure. So here's the objectives we're going to go over. So let's define a VPN, a virtual private network. So this establishes a protected network connection over a public network. So let's define kind of the history of this. So back in the day, if I had an office, let's say here in Reno, and I had an office in Vegas, and I hosted data centers here in Reno, could my office in Las Vegas reach those data centers? The answer is no, because they were connected to the internet, and those internal IPs, we don't expose to the internet. So what was the solution? I'm talking way back in the late 90s. It used to be something called a dedicated circuit. So your company would pay like not an MPLS, it used to be called like a frame relay circuit or a T1 line. If you guys remember those speeds, it's like 1.544 megabits per second. And it would literally be a dedicated copper wire all the way from Las Vegas to Reno that would be just for your organizations. And how much do you think that costs? A lot of fucking money, right? Monthly to the ISP. So a VPN does that exact same thing just logically. So now instead of buying that dedicated circuit, we'd have our regular broadband ISP connection that's like, nowadays, what, fiber 2.5 gigs or whatever. And to connect our offices, we'd build a tunnel. And we called that a virtual private network. We did that by just encapsulating our packets, saying, hey, head towards this destination IP. We do this on both sides. And once you get there, we're going to establish a tunnel, and we're going to encapsulate all that tunnel traffic. So it's going across the ISP and the internet, but all of our user traffic between offices are now encapsulated and private, okay? And that was the first step. And then we added encryption on top of that. So instead of just having an encapsulated packet that didn't show the original IP addressing, if someone was a man in the middle, guess what? We didn't encrypt it, so we can still see the data behind that though, because we're not doing TLS all the time between, sites. So then we added encryption on top of our virtual private networks. That's all it wants me to teach. I could talk about VPNs for hours, so we're just gonna move on. Okay, remote access. This is another VPN solution or technology, but this is for our remote workers. This is where we deploy a VPN concentrator, whether that be a dedicated hardware appliance, a firewall, a router, and we set up TLS or some sort of VPNing technology that allows all of our remote workers to get into our enterprise. So we call that remote access. So a user using the public infrastructure, internet, to access our VPN concentrator, which has a public IP, to build an encrypted session to allow them to get access into our enterprise resources that we don't expose to the internet. Okay, tunneling. So tunneling is the basis of VPNs. This is how VPNs work. This is how we get remote sites to actually connect to each other. So right here, this is an IP packet, guys. See, we have our regular IP header that have the source and destination in it. Then when we tunnel, we add an additional header here, okay? That additional header, ESP is encapsulation security payload, is going to allow us to connect to a different site over the public internet. Then we have this mode called tunnel mode, which gives us a whole brand new IP that we make up, okay? So this brand new IP is going to be our VPN connection. We have our encapsulation security payload here that's going to protect us and authenticate us, and then the original IP header. All right, do you guys want me to go over TLS again? I think you guys got it, okay? IPsec. This is one of the most common VPN site-to-site connections. IPsec does what TLS does. It just encapsulates, encrypts our payloads, and also does authentication, okay? So IPsec has two modes that I want you to memorize, transport mode and tunnel mode. With tunnel mode, you're actually going to encrypt the original IP header. You're going to protect it, which means if someone's doing a packet capture, they're not going to be able to see the original IP from which you're originating from. They're just going to see your VPN's IP, which is nothing, right? It's something we made up. It's a private IP address. But IPsec is how we add encryption and authentication to our VPNs. Okay, another software-defined networking technology here is called SD-WAN. This is a virtual WAN architecture that allows enterprises to leverage any combination of transport services to connect our users to our applications and enterprises. So let me break this down a little bit. So let's look at this design. So you see this branch office here. We have users here that need to connect to our company resources in our data center. And then we have company resources in the cloud, okay? So we need an ISP connection. How do our users get out to the internet? We're going to create an ISP connection for all of our users at this branch, this office. And we want redundancy, right, guys? We always want two ways out, that physical, logical redundancy. So we have broadband connection here, which is like fiber. And then MPLS, which could be like, that's a dedicated circuit in the ISP now. It's called the MPLS circuit. So how do we choose which one the users are going to use here traditionally? We'd have to go into the router and do very specific route policies that says, if this source IP is destined to this cloud instance, then send out this connection. And it was really a manual effort. And you have to do that at each branch site. And then maybe you had quality of service tags that said, oh, if our MPLS is being used at a 99% bandwidth capacity, send all traffic out the broadband. And that's something we had to manually configure per site. SD-WAN gets rid of that. SD-WAN centralizes that capability of saying, hey, we're going to allow you to use any form of transport that you want, and we're going to configure that from a single pane of glass. So it simplifies our network management and gives us centralized control over all these branch offices and how we want to route traffic. SD-WAN typically comes with like an SD-WAN controller that you have to deploy, and all of our offices will connect to that controller, and then they'll have their regular ISP connections, and that controller is telling all these routers at all of our branches how to route their traffic, okay, from a single centralized place. So it's supposed to reduce complexity and improve efficiency, but obviously you need a skilled worker or network engineer to set it up. But that is SD-WAN. A single pane of glass that allows you to be transport agnostic for your user traffic. All right. SASE, Secure Access Service Edge. It's going to do the same thing as SD-WAN does, but guess what we're going to add to it now? All these different security functionalities. Now we're going to add VPN concentration in there. CASB, which is called Cloud Access Security Brokerage functionality to it. And we're going to add, see all this? Y'all ready for a bunch of acronyms? Okay. It's going to add SWG, Secure Web Gateway, which is similar to that web application firewall we talked about. It's going to do protections and act like an endpoint for like VPNs. CASB, Cloud Access Security Broker. That is an appliance or tool or technology that allows us to enforce policy on our user connections to the cloud. Firewall as a service. So the SASE appliance does our routing, does a VPN concentrator, secure web gateway, applies policy and monitoring from users to the cloud, and then it also does firewalls functionality, permitting and denying layer 3, 4, and 7. And then it's also going to provide us zero trust network access. It's also going to do contextual awareness and conditional access at all of our authenticated sessions to and from on-prem, cloud, and user. Got it? All right. Yeah. Yeah, I know, it's a lot. Let me break that down for you for the test. If there's a question that says, I need to combine networking services and security services for my branch offices to the cloud, SASE, okay? It's a combining all these next generation technologies, okay? Mainly related to the cloud and SD-WAN. So remember last slide we talked about a UTM, Unified Threat Management, and I said that combines all these security technologies. I wasn't lying, that's more for on-prem, okay? SASE, SD-WAN is more of like a cloud infrastructure thing, okay? That's combining all these security functionalities and our WAN networking capabilities. All right, any questions? All right. My buddy gets paid a lot of money from Cisco to sell this type of shit. So like that little spiel, he like creates that to sell millions of dollars to customers and stuff.
I mean, the customer just says, yay!
Depends, yeah, it depends on the customer. All right, selection of effective controls. This slide, sometimes I like to skip it. All this is saying is like, hey, all the shit you've been learning about all this different infrastructure that you can implement in your enterprise to protect your environment, you have to make sure it makes sense, that there's a cost of benefit analysis, that it meets certain compliance. Like don't put something on the network to help you do data loss prevention and then be like, oh, hey, but it doesn't actually meet this compliance we have. You know, do things that make sense for your environment, your organizational policies, based off your organization policies and your sector and your different compliance, okay? All right, let's do our quiz and then we'll go to lunch.
There it is. There's that, the question.
What was the first question you got?
It's the third question.
Okay. Let's do this quiz.
Yes. Unifying. There you go. Bless you.
Thank you.
Yeah, VPNs don't increase connection speed either, guys.
Mm.
Okay, it adds more to the packet actually, like more headers and stuff. Oh, so yeah, look at that sassy one. It's consolidation of all the shit.
In the cloud.
Cloud, yes. All the buzzwords. All right, I'm gonna put a timer up here. We'll just do another hour and a half lunch.
What's the name of that taco place down there by,
By the Edison Yard.
yeah, what's the name?
Daddy's Tacos.
Daddy's Taco.
Shit smacks.
Wait, what's the name of it?
Daddy's Taco.
Daddy's Tacos.
Yeah, it's pretty good.
Oh, okay.
It's like right down the street from here too.
You go get the birria.
What?
The birria.
They got a good
Shredded
carne
beef.
asada burrito
It's
too.
like shredded. It's like shredded beef. You know what au jus is?
Yeah.
It's basically shredded beef, and they give you the sauce that it was made in, like au jus, and so you dip your taco in that sauce.
Wait, what are those called?
Birria.
Tacos.
Billy.
Like,
I've
B-I-R.
been saying it the wrong way the entire time.
How do you say it?
I have no clue. But man, I wasn't saying it that way.
Yeah.
Yeah, and then they're like, the shell is actually like, it's fried down on some cheese and then they fold it.
Yeah, fried down on some
Yeah.
cheese as an option, and with the sauce on the
Yeah.
actual tortilla.
Yeah, I love those.
Dude, they're so good. It's
They
like it's
are.
literally the best way to describe it is like the Mexican version of like a French dip.
Yes,
Yeah.
sir.
Yeah, that's a good way to describe it actually.
Yeah.
When you see them, I've never made them myself, but when you see them getting made, yeah.
Delicious.
Yeah, I've never made birria actually. It can't be that hard. But just
I don't think so.
It's the beef part, like the seasoning to get that beef cooked down right.
Mm.
That's the hard part.
Coming. I did that. I can do it. You can do it because I got one of those flat grills.
okay.
Oh, shit. I'm gonna try that when I go home.
Hell yeah.
Try to make it when I go home. I mean, I'm gonna go there. It just, the name of the place sounded a bit questionable, and I didn't know if you guys were sending me to.
You never know stuff.
Exactly. Exactly. male strip
Yeah,
club
they
or
don't sell-
something
they
like
actually
that.
don't
It's
sell
like,
food
son
there.
of a bitch.
Oh, you wanted the food? Oh.
There's only one strip club for food here.
Sushi.
Sushi.
Whoever made that ground beef's pretty good.
I didn't bring any ground beef today. I ran out. I was gonna make steak sandwich last night. I was like, no, I'm just have pizza and studies.
Yeah.
I almost fell asleep when I got home. I was like, get up, bitch, come on.
Why? It's not like you were crashing out from your 7 coffees earlier.
Yeah.
I'll show you me crashing out, Jordan. You buy tires yet?
No, but I did get a quote.
1,200?
Hell no.
Fuck,
Okay.
double that.
Hmm?
Double that.
600?
Yeah.
550.
Yeah, they were trying to like sell me on a warranty, and it was like 2,700.
Mm-hmm.
But that's like if you get a flat, they just give you a new tire for like a limited amount of time. But I don't really care about all that, so
Like 69,000 miles.
69,420. It's a pretty cool deal though. They're like, yeah, like up to this many miles, like you can just keep shredding tires, and we'll just keep replacing them for you. I was like, oh shit.
That'd be a bad idea.
I don't really expect to go through tires like that though.
That's what we should do for the heavies.
Honestly, literally. But I don't know if Discount Tire accepts,
Wheels like that?
or is it
No,
like
wheels
if we
are-
can go through them or not, I don't know. That would be smart as fuck.
Makes too much sense.
Yeah, it makes way too much sense.
Video, I'm going to show you how to set up a privacy VPN in Unify using WireGuard or Please tracking the process it can configure it. We choose Linux. In some different companies, it may have the option for router. Go over to your VPN account to WireGuard.
I don't really want to pay for that.
Bring it over here to settings.
Painless.
Choose wire. Take about roughly 30 seconds to connect, probably a little bit less. Same thing if you
Or that's how I got my first
VPN
tires I ever
connection.
bought.
Click on Open
Well,
VPN.
get their credit card.
Make sure that you
Credit
have
card, I
not
don't know,
used
it's
in
kinda
your
like a
network
loan, I
settings
guess, but
any networks that
they'll ask
The
you
only
if you
option
wanna
they
do
have
payment.
is credit card.
VPN. Once you have these configured,
I guess you
you'll
have to
see
give
them
me a
here.
card,
You'll
yeah.
see the connections.
That was
Something
a
of
while ago.
note, make sure that you have not
Bought some
used
Pirellis
in
on my
your network
mobile
settings
phone.
Oh, yeah, I
any
remember you told me
overlap
about
with these particular networks that are in here, or you may have both then generate a config. So you
That shit's funny though.
Whoa. Jesus Christ. God damn. Like when I go to the dealership to the Lexus and they're like, oh, you need tires. Like, yeah, I'll go find my own tires. 7 to 9:45.
What class is it?
It's a 7:04 introduction to I sat there yesterday and listened to them talk. I was about to die. Class. Lecture run.
I have to go in that fucking school right now.
It's tough, man. It's tough. Human factors in cybersecurity. This is all a lecture, nothing but he talking and just there going, okay, got some notes, read some.
Case studies or something.
Yeah. And then they'll hit you with assignments, probably gotta write a 4-page paper, you know, get it turned in. And then,
How many days a week is that?
once.
Oh.
I only took one class, because I know, you know what I mean? And I'm like this, I'm like, oh, I'm gonna go take one in-person fucking class, and I can't get to it.
Be good. You see how one class goes.
But, because it's a graduate program, they're lenient, so you can, if you take a in-person class, let's just say today I'm traveling, this week I'm traveling, it's okay for me to hop in online. They don't, you know what I mean? I'm like, all right, cool, I'll do that. And then all I gotta do is show up one time during the month, and I get the like, they give you like VAH, they give me for the entire month. My buddy used to fly to San Diego once a month, got like almost $300 every month. Here it is, man. 511 questions. I'm only at 16% on that bad boy. Role-based access control. RBAC. When you set up the electric and stuff there for the house.
Yeah.
Do the spread out one, where it spreads out over the year.
The electric.
Yes, where they give you an average cost per month, and they charge you that. Mine went down by a lot of money this year.
Yeah.
Oh yeah, that shit went way down.
I gotta see what my first bill is like.
Depending on the size house, maybe about 200.
Yeah, maybe.
Farming is the best reason to come for an audit in a banking environment. I would say regulatory, but you're a bank, so. It's probably service level. Yeah, regulatory. MCC.
Why is that? Total is 947.
That's weird.
So why does it do that?
Finding that here.
I don't understand. Well, let's give it a shot. You want, there's an unsaved item. Do you want to discard it? Where is the unsaved item?
Oh, brute force. At 511, the master exam. That shit is.
It's hard. It's tough.
No, it just because you're going through the questions,
Yeah.
you're just going and going and going. I don't pass them. I was just like, all right, cool. Let's get to the next one.
Yeah.
Let's get to the next one. But I would love to get that Network Plus. Get my hands on that one, and that my mission is complete after that. Oh yeah.
Ours is 600 a person,
What?
and And then if you want to do self-paced, it's like $60.
That's it?
Mhm.
Fuck, I couldn't find you 2 years ago.
True story.
Hold up, I paid the 600, you know what I'm saying? Do the class.
Yeah.
I'll be so far ahead right now.
Yeah.
Fuck. Oh, when did you say you got out?
2023.
So you probably heard of, where they'll give you the certs so that you go get certified and the Army would pay for it?
Yeah,
I forgot
CA,
the name of it.
Army CA.
Yeah, I did it.
Mm-hmm.
I did it when it first came out. And so I was nervous because I was like, fuck, I'm leaving.
Yeah.
Are they going to tax me because I didn't do the exam? But I did all the classes. I was accounted for and everything. And they said, you didn't do the exam? I was like, no. She's like, all right, man, you enjoy your retirement. I was like, what?
Thanks.
'Cause
Yeah.
you know, normally, if
Yeah.
you don't do the exam right after, they're like, yo, give me my money back. Give it back.
Yeah, they'll still do that too. Hold on.
I was so surprised. Because in the aviation world, a lot of these kids that do the aviation, they're not thinking, you know?
Mm-hmm.
I'm like, bro, you guys have so much potential. You're doing aviation. You know, not all the time you work on a helicopter.
Mm-mm.
You have a lot of downtime. Use your downtime wisely.
Yeah.
Man, I got scolded by the first time because, you know, an infantry guy going into an aviation company is not good. Never good. And I told a couple of my privates, hey, listen, y'all going to start taking one class a semester. Just one. That's it. That's all you got to do. And they went and complained that I'm threatening them. I'm like, what are you talking about? It's a part of development. What the hell are you talking about? I had to go talk to Top. Top and say, hey, man, I know, you know, the infantry guy got it, but you know, gotta tone it down a bit. I'm like, oh my God. And after that, I don't mention nothing to them, bro. I just leave them alone. I'm like, y'all stupid.
Kids are soft as shit nowadays.
When I left, I tunk up the deuce.